Alright, this is my reassessment video on forces, the very first standard, and what we're going to do is we're going to try to find the tension it takes for this guy to pull this box up this hill. How hard he's going to have to pull the rope to get the box to move up the hill. So we got M1, which is the box, 2.3 kilograms. The coefficient of friction is 0.17. The tension is what we're trying to find, and the angle theta is 42 degrees, so it's a pretty steep hill. Now here's the free body diagram. We got the normal force, tension, the force of friction, and the force of gravity pulling down. So we're going to use Newton's second law, and we know that the acceleration is going to be 0 because we're just trying to get the box to move. And so if the acceleration is 0, we know the sum of forces is going to be 0. So sum of force in the x direction is going to be 0, the sum of force in the y direction is going to be 0. But is going to equal 0. So the sum of forces in the x direction is tension minus the force of friction minus mg sine of theta, and we can switch that around to get the force of friction equals mg sine of theta minus t. And the sum of force in the y direction is the normal force minus the force of gravity times cosine theta, and we switch that around to get the normal force is equal to force of gravity times cosine theta. So if we want to find the tension, we gotta use these two right here. We're gonna plug in n. We're going to plug in mg cosine theta for n because we know the force of friction equals coefficient of friction times normal force. So we'll use that. The coefficient of friction times the normal force, which is mg cosine theta, equals mg sine of theta minus t. Whoa, right here, sorry. Normal force of friction, mg sine of theta minus t, right here. And then we plug in the numbers. We solve for t. We get coefficient of friction times mg cosine theta minus mg sine of theta. Plug in the numbers and we get the tension 19.125 newtons.